Okay. Yes, so it started. Good, all set. So nowadays, we live in times of unreliable data due to COVID, COVID lockdowns and war conflicts and general volatility within supply chains. So it is important for an organization to cope with such a volatile market and strive for optimal forecasting. But how? And also the question how one can measure the impact of unforeseen disruptions inside and outside of an organization. So in today's webinar, we will find the answers, and we will also present you various business cases and different algorithms within SAP IBP that decrease the level of uncertainty and help you to make informed decisions. So this is our agenda for today. We will start with a short concircle introduction, and then we go to IBP solution itself. Right after that, we go to forecast planning using advanced planning algorithms, and after to S and AOP heuristics run versus the supply optimizer run showcases. And last but not least, Q&A session. So we will be glad to answer your questions, which should arise during a webinar or after. Please put them in the chat and we will deal with them later. To our speakers, my name is Aigerim Rabe, also known as just Gera. So I am a marketing manager at concircle. Then we have our wonderful IBP consultant, Halyna and our digital supply chain team lead, Martin Baldov, who will now introduce you to our concircle company profile.
Okay, thank you for the introduction, Gera. Okay, can you hear me?
Yes, we can.
Yes, perfect, thank you. Okay, sorry for the hiccup. Thank you for the introduction, Gera. My name is Martin. I'm the digital supply chain team lead, and I'm very thrilled now to introduce concircle to you.
Yes, I'm clicking.
So concircle was founded 12 years ago with the core vision to support industry clients in their vertical IT integration journey. Starting from just the 3 founders and owners, we grew in the meantime to a team of 80 in, as you can see here, 4 countries: Austria, Germany, Slovakia, and Switzerland. All of us are sharing the same passion and for the same vision, and due to our focus, we also had the honor in the meantime to support over 120 clients in over 350 successfully implemented projects. We are dedicated to the European market and are therefore focused mainly on the DACH region as well as the CEE region. The focus on vertical IT integration is also reflected in our company structure. The digital supply chain team designs and implements supply chain planning processes. This starts at strategic budget planning, includes tactical sales and operations planning, and ends at short-term detailed production scheduling. Then next, our digital enterprise core team digitizes the entire enterprise. Their goal is to ensure smooth and efficient operations across the entire organization. And lastly, the digital manufacturing team is dedicated to increase the productivity potential directly on the shop floor. Connecting machine data with enterprise systems and enabling transparency provides the foundation for good decision-making. As a valued SAP partner, we consult and implement processes in SAP software such as SAP IBP, SAP S/4HANA, but also, for example, extended warehouse management and SAP manufacturing execution. But even SAP sometimes cannot fulfill all the requirements from the vast customer base. Therefore, we also developed our own products, which close some of the gaps and help customers to better utilize the potential of their digital landscape. Some examples are mentioned on this slide. For example, ConDP, Con Demand Planning, which is a flexible planning tool in S/4HANA, and also CONOS, Con Operation Scheduling, which is a modern detailed scheduling board as well for S/4HANA. So why concircle? So in the past 12 years, we could prove our deep knowledge and understanding of the manufacturing industry. Originally, most of our customers were in the mill industry, like paper, steel, textile, but in the meantime, we also had the opportunity to implement projects in the areas of automotive and aerospace, metal and plastics processing industry, as well as FMCG. concircle is still owner-led, and we live an open communication culture. We meet our clients where they are and not where we think they should be. This also includes communication on eye level across all ranks, from the C-level down until the shop floor workers. One factor of our success is the wide adoption of the agile project methodology. This ensures that our customers are involved in the implementation right from the beginning. Regular feedback cycles with the key users increase the satisfaction of the delivered solution, which is also reflected in our very high rate of successfully completed projects. I already mentioned earlier a few of our own products. So if we find a more innovative solution to solve certain complex industry-specific needs, we do not shy away from creating our own products. And lastly, we are also dedicated to the UN Sustainable Development Goals, which we are supporting on the one hand internally in our own processes, but also by developing solutions to support our customers reaching their goals. So apart from our production scheduling and supply chain planning solution, our product portfolio also covers the areas of variant configuration, quality management, production execution, and workflows. One product I am personally very excited about is our blockchain connector ConUBC, which enables a direct interface between a blockchain and an ERP system for a seamless integration of trusted business data across the whole supply network. We are already implementing the first projects with this new solution, and I'm thrilled to follow its progress, especially in the sustainability space. So, okay, I thought I just heard something. But now I would like to hand over for the main part of our presentation, and I would like to give the stage to Galina.
Welcome, everybody. I will take the control. I'm Halyna I'm SAP IBP consultant. Before I started with IBP, I had been engaged into inside production planning and optimization processes in different industries. I used to work with the various forecasting approaches and planning systems and opted for integrated business planning by SAP. Today, I'm going to tell you about some useful features in IBP that could be helpful in mind-blowing reality when standard approaches fail to forecast properly. Now, a little bit of historical background. Originally, some planning functions were covered by R3 in its simplified version. In 1998, APO was introduced as a supply chain planning tool. Being integrated with ERP, it was meant to do the transactional work. When SAP IBP came out, it was not really an heir to APO, but a new analytical approach using the concept proposed by Oliver White. IBP benefits HANA database technology doing its on-the-fly calculations. It has scalable model and intuitive user interface. It proposes end-to-end visibility and quick response to changes in planning process. Balancing demand and supply is the core of IBP. integrated business planning proposes various functionality based on its 6 modules. The first one is IBP for demand, with its demand sensing and statistical modeling features that is used to model up the demand to the point of sale. IBP for S&OP aligns strategic and operational planning, taking care about financial KPIs. Inventory uses multi-scale inventory planning to minimize the stock outs and to increase working capital. IBP for supply and response helps to meet the demand with efficient capacity utilization and sequencing the demand by priority. The DMRP actually improves the functionality of standard MRP, being tied directly to real integration and using special stock buffers. As for supply chain control tower, it offers performance management, exceptions handling, task management, and real-time monitoring. Forecasting features in SAP IBP leverage from embedded time series, regression-based machine learning algorithms, and today I would like to cover a few of them to show their practical use in hard-to-predict reality. What do we see today? It's COVID impacting not only the forecast accuracy, but ruining the whole strategy of planning. Stuck in Suez Canal, disrupting global trade. It's war in Ukraine that takes lives and destroys businesses, destroys trade line, and making any future elusive. Classic approach to manage supply chain is hardly applicable for a lot of companies now. So it makes sense to use complicated algorithms to cope with complicated issues. I'm going to focus on gradient boosting, multilinear regression, external forecasting model, and using forecasting algorithm, maybe not in that standard way, but to predict not only quantities, but other key figures, like, for example, price. Let's start with gradient boosting. Gradient boosting is a machine learning algorithm. It can be useful in planning when various conditions are to be considered during forecast calculations. That could be, for example, price, that could be temperature, different events happening regularly, promotions, some competitors, marketing activities, whatever. Gradient boosting consider independent variables to explain the historical values and to calculate the forecast based on the results. Each tree in gradient boosting is a decision model. The gradient boosting performs the repeated optimization on several decision trees and considering their possible consequences. The goal of the model is to determine which tree on which level should consider their independent variable and to get the results which will help to build the forecast. The algorithm is less sensitive to outliers than the others algorithms, and it also can catch the irrelevant variables, and it doesn't consider it in its future calculations. As opposite to multilinear regression, gradient boosting can deal with the cases when the multiple dependencies can be observed between the predictors. As for multilinear regression, it is a technique to model the linear relationship between the dependent variable and independent variable. The system looks for coefficient to multiply the independent variable width. In that way, it gets results that are close to historical values. When you know the relationship between the independent and dependent variable is linear, this algorithm is actually the best to use because of its less complexity comparing to the others. But multilinear regression is quite sensitive to missing values and outliers. This could be solved within IBP functionality using pre-processing steps. We can clear the data, like prepare it before forecasting, and we could substitute missing values. I would like to show you how it works in the system. Just a moment. So SAP IBP has two different interfaces. It is a Web IBP Fiori interface and Excel interface. Here, how it looks like. Excel interface is quite friendly and familiar to users, and it combines the advantages of standard Excel functionality and the functionality of IBP. This is the predefined template that will show the results of gradient boosting. Here we can see the product, the location, the customer, and key figures calculated or downloaded, for example, like actual quantity. I will enable the chart to get better visualization. For example, for actual quantity, we can show it on a chart. It is like an orange line. We will also use statistical forecast quantity and ex post forecast quantity that was calculated by the model already. We will take the product and see actually how the model builds the forecast. Statistical quantity is calculated by the model, and the temperature here is used as an independent variable influencing forecast value. As the chart demonstrates, the algorithm catches quite good the behavior of the product and builds reliable ex post forecast that is close to historical values. The model could be run here in Excel interface. When we run a model, we can use the time buckets, a time period, like choosing the month or week, any period we are going to use for forecasting, and choose the model among a lot of the models available that we have predefined before. But the general settings are done in web interface. I will jump into it. Here are the models. There will be now the models for a planning area. I will choose the multilinear regression to tell a bit about the pre-processing steps. So that is the model for multilinear regression. As I've mentioned before, we are using outlier correction for these algorithms because the data set is not normally distributed. Also, the adjustment is done for seasonality and trend. Previously, the data was checked to define the demand type using forecast automation job. Here we see the forecasting steps and the independent variables such as temperature impact and events impact. It is football championship that impacts beverage sales, And the model consider it in future for the events like this to calculate the realistic forecast. Let's go back to Excel to see how MLR performs. I have predefined the pretty similar template here. Let's see how it works. MLR X post forecast quantity, MLR statistical quantity. So you can see the X post forecast quantity is very close to historical values. It builds quite relevant forecast. Maybe it's slightly worse than gradient boosting does, but it is definitely related to historical data and linear dependency of factors to sales quantity. In warmer months, like in summer, where the dependency is more noticeable, the algorithm proposes accurate forecast. We could easily drill down to weeks, and we will do it, to compare different results and to see how it goes with MLR and gradient boosting together. I will choose it from some period in past. Okay, let it be maybe April. I'm choosing week period here, and I will add the exposed forecast for gradient boosting, and I will add also triple exponential smoothing just to see how these three algorithms work. Forecast quantity, okay. So what do we see now? We see the forecast quantity calculated by three algorithms: multilinear regression, gradient boosting, and exponential smoothing. Let's go somewhere close to current period. It's June now, okay. So what do we see now? Like all of these three algorithms are quite good, and the ex-post forecast calculated by them are quite close to actual quantity. Like you see, maybe the gradient boosting is the best one, but MLR is also good. We can see here the triple exponential smoothing performs also good, but what's going on here? Like the value is quite high. Why? Its actuals are not that high, and the system predicting past, but anyway, like twice higher. What's wrong with triple exponential smoothing? But this algorithm smoothes usual average. Let's see the historical values from the June last year, for example, to understand what is going on. That is 2021. You see in June, the actual quantities were high. That's why the triple exponential smoothing gave the high forecast. But it was not because of high sales, actually because of temperature, for example. We see here the event impact. It is a football championship that impacted the sales. And gradient boosting and multilinear regression takes into consideration this event impact. So when we go back here and check when this event will occur in future, so let's go a little bit further, maybe looking for some jump. Okay, this is December of current year. And we see here that the event repeats. We will get also football championship here. Actually, it is winter, December, like month number 12, and the temperature is really low, so it shouldn't impact the sales, but vice versa. And the baseline is really low, but the system says that it is event that is impacting our sales, and it will increase the forecast. So I mean the models like multilinear regression and gradient boosting, they are considering the event's impact. You can add the baseline with, for example, negative temperature impact and positive event impact and get the predicted statistical quantity calculated by the algorithm. This same method actually can be chosen for price forecasting. We can choose gradient boosting, multilinear regression, and any method that is like more common to use to predict quantities, but we can predict also price using different independent variables. In our case, it is energy price that was influencing the forecast, and we predict somehow the actual prices to understand what is gonna happen in future. The planner can choose the algorithm on its own, making the decision based on his expertise. And it's actually possible to combine the different variants of models in one, different variants of algorithm in one forecast model. In this case, when we combine, the system will utilize different forecasts considering the calculated error as an argument. IBP for Demand offers a wide range of embedded algorithms, but anyway, if there is something specific that is not covered, there is always an option of custom algorithm to be used instead of traditional one, or together with it. If there is some specific case, or maybe it's just simply more convenient for the company to use the method that is tested on practice, Planner can absolutely freely use the external forecasting algorithm. So how it works? The external algorithm can run in a third-party development tool outside of IBP actually. When you trigger the forecast, SAP IBP sends a notification to external system to make necessary calculation. The external algorithm extracts the relevant input data from SAP IBP, then it calculates the forecast and sends it back to SAP IBP. You can add one or more external algorithm to a forecast model. You can always change the parameters on your own. You can also actually use the external forecast algorithm together with the embedded ones and to check the statistical error, to analyze the performance and to choose whether your external forecast algorithm is better, or maybe embedded algorithms are nice also. Using the variety of forecasting options that SAP IBP provides, it becomes easy to find the one that will be helpful in adapting to high volatility of the market. Wide classification options and calculating the forecast by machine methods help to win time and to balance the situation when unexpected changes are happening. Now I would like to go to production planning a bit and to demonstrate the showcases where the heuristic and supply optimizer do their best in supply planning. Here we have two showcases to demonstrate the behavior of planning algorithms when we get the capacity shortage because of factory, like planned or unplanned shutdown, and raw material shortage because of non-delivery from one of our vendors. In both cases, we have an example when the product can be produced in two different production versions. Both of the versions consume the same resource capacity, but the alternative one has another bill of material. I will show how it works in Excel. We have here the predefined capacity supply key figure for different kind of resources for location 1010. We can also use charts here to understand what's going on. I will use several planning versions to demonstrate the showcase. The base version will be used to demonstrate how heuristic performs. I will open the upside version. The upside version is gonna demonstrate the example how the optimizer does when we have capacity shortage. And the downside version is for showing the case when we have a raw materials shortage. So as for the charts, we can also use some specific resource here. And for example, indicate that we use upside versions and we see what's going on here. In November, there is factory shutdown. How does the heuristic and optimizer treat this case? Actually, I just would like to add that using the different planning versions is a good thing to use for a planner. You can simulate different scenarios and then to compare and check which one is better one. And when you have forecasted the figures that is done quite fast, you understand which is better, you choose this version as the main one. So here the capacity is zeroed for November. Heuristic doesn't consider lack of the resource because it thinks that all resources are infinite, but we can monitor the situation checking capacity utilization level. Optimizer will build up the stock previously to prepare for the shutdown and to increase the production quantities respectively. Let's see how capacity is loaded on the charts because it will be a little bit better. Here we see the hidden map that shows from the left side it's heuristic, from the right side it's optimizer. As for the heuristic, the supply planning heuristic, it ignores capacity constraints and assumes all resource capacity are infinite, you see here. However, we can always track the normal utilization level violation and set some special alerts or monitor regularly the values using analytic charts. The planner will get the idea about the capacity utilization and can drill down certain time period per categories I will show just now. As for optimizer, it respects the resource capacity unless the other option is not set. For example, capacity can be expanded. Actually, you're flexible to manage your warehouse resources, time schedules, seasonal workload, plant shutdowns, just to indicate the level of impact on your own. In November, we can see the weeks for month 11 are grayed out and capacity is not loaded. For heuristic, the situation is different. But for example, if we go to another chart, we see here a capacity usage, like in hours, not in percents. And to understand what's going on in February, how the resource is loaded, we could drill down. I will drill down by product family and to see which product families, well, actually, it can be used by product, by brand, by whatever. And we can see which product family loads the capacity. As for fulfilling the demand, the heuristic and optimizer also treat it in a different way. This supply planning heuristic usually satisfies the entire demand. You can see on the top, the chart is for infinite heuristic. Insufficient supply will be balanced by negative stock. It could be used for a planner to check, could be useful like when a planner checks each location product level and see where the stock goes below zero, just to understand how much capacity would actually be required to fulfill the demand on time. Heuristic will show the consensus demand in different way. We see here we start planning from June, so the first months we are not able to satisfy the customer demands. And after things go better because we build up some stock, we have the production, and we are able to meet the consensus demand. Heuristic, optimizer offer two modes. It is profit maximization when the decisions are made considering total cost of the finished good, and delivery maximization. The goal of the delivery maximization is to satisfy all customers' demands, respecting well the hard constraints. Fulfilling the demand could be violated by other constraints like resources, costs, minimum capacity load, etc. We can check gross profit here. When checking gross profit calculation for all three showcases, we see that Heuristic offers maximum reachable revenue in case we would be able to fulfill all demands from customers. The optimizer respects the constraints in case of the resource unavailability or some raw material shortage, and it could be used for financial reviews or comparing the results for different scenarios. As for the second showcase, I will remind it is raw material shortage, and the supplier of the component, which is used in the main production version, let's imagine he has some issues and we will not get any receipt during several months, like shown here. So downside version, we should pay attention to downside version. So this one was the component used in the May version, and from August we get nothing for several months, but still we have actual component that is used in another production version. What's going on when we have the situation like this? The optimizer will switch to alternative version. Let's check. This one is the main one, and we see for downside version that nothing is produced since August. But it switched to alternative production version and produces here. Heuristic doesn't change the receipts, but it will show the negative stocks for raw material. If the planner works with heuristics, he has to monitor the projected stocks and to check whether we have negative stocks. For example, we can try to simulate here. We will choose, I will check the, okay. We will choose the component and we'll try to simulate how it goes. I will adjust the values manually. Like this. So I'm gonna do 0 values for the base version for the heuristics. We can save the data. And to run the optimizer. To run the heuristic, sorry, for base version. Actually, when we are running heuristic or optimizer, we can use any version, so it's quite nice. we'll see the status. So we can actually check the errors and status and monitor how Heuristic performs in a business log. So it's quite fast, it finished. Let's refresh. So what do we see here now? The heuristic for base version showing the negative projected stock. So it says we actually face the lack of the component and we are not able to produce. To sum up, the best benefit of the time series based heuristic is speed and easy to understand to interpret results. Though it sounds like unconstrained planning, but the algorithm considers some of the other important constraints like lead times, manual adjustments, minimum lot size, and inventory targets. Once we have a good starting point for supply planning, we can always go for constraint-based supply planning with optimizer that is more complex but more reliable as well. That is all from my side for today. In case of any questions, you are free to ask.